So I've gone ahead and found a source on how to use a mutex. Let's try lockguard, and let's see how to use this. And it looks like I have a handy example here. So it looks like here, what they're doing is creating the mutex. And it looks like here, this is where the mutex is being used. So I'm gonna do the same thing. But first, how does the scope of this thing actually work? I guess the answer is right about here. This is the type of the mutex object, so I'm gonna copy that real quick. And now to use this mutex in my own code. So I'm gonna put the mutex right about here. And that's because I want the mutex to be accessible within the waitForTrigger function. Now, what I forgot to do was link the library. So let me check what library it is first. And it looks like it's the mutex library. So include mutex. And I'm going to call this mutex access control. So now, how do I actually use the mutex? I'm going to take a look back at the source that I found. And it looks like this bit here is how you actually use it. Now I am accessing the shared variable within every iteration of this while loop. So that's the scope that I have to block off. So that's where I'm going to use the mutex. And I have to change this to the name of my mutex. And that's done. Now, let's see if things are a bit more synchronized. So now I'm going to run this thing. And I'm going to enter no. And I see the same result as before. So it's not fully synchronized. Now there is one more place where the shared resource is being accessed, and that is here. So what I'm going to do is use the mutex here as well. So I'm going to add this bit here, and here we go. Now let's see if that solved the synchronization problem. So I'm going to type in no, I see no, and then the loop is exiting, and I see the thread has finished, but it's on its own line, so everything is synchronized. So this was a simple demonstration about how multithreading works. Practical use of this concept is very complicated, and there are many other sources available which go into more detail. That said, just to keep things simple, this is where I'll stop with multithreading. So now, let's get back to our password generating program. Now, this program is far too simple to actually require multithreading, but I'm going to implement it anyways. So, where can I possibly use multithreading? So, let's say that what I want to do is calculate how much time it takes to generate a password. Now, before I do that, what I'm going to do first is make a copy of this file. And then I'm going to rename it. Alright, so now that I've made a copy of the program, what I'm going to do is calculate how long it takes to generate a password. So I'm going to make a timer thread here where the password is actually generated. And the first thing that I have to do is start the timer. Then I'm going to end the timer thread here when the password has been generated. So the first thing that I have to do is make a function to calculate how much time has passed. This is the function that I'll be running in the timer thread. I'm going to put this function below the class but above the main function. Now this function doesn't have to return anything. All it has to do is print to the terminal how much time has elapsed from when the function started and then when it ended. So I'm just going to make it a void function, and I'm going to call it timer. Now, an easy way to tell how much time has passed is to get the time when the timer starts, and then the time when the timer ends, and then find the difference. So, when the timer starts, what I want to do is log what the time is. Now, I'm going to store the time in Unix time, and Unix time is basically the date except in terms of some number of seconds or milliseconds. The advantage of Unix time is that since it's just a number, it's much easier to do calculations on it. So, how do I get the Unix time in C++? And let's try this. And I think I'm gonna try this answer. They are using chrono, so I guess I have to include chrono. Now, let's see what the answer is. So, I think in this part here, what they're doing is getting the system time. So, I'm just going to grab that real quick. And since I'm creating a variable here, I need to know the type of this variable. And the type is auto. Now, when auto is used, the type of the variable is retrieved from the value which is assigned to the variable. So in other words, when assigning a value to a variable of type auto, you don't have to worry about setting the type of the variable beforehand. Anyways, I guess we're using auto. Makes things easier, I suppose. And let's call this thing start time. And the value is the system time. Alright, so what about the rest of the answer? Now, what about this part here? What is it? I'm seeing the mentioning of the word cast here. Now, cast is basically another word for convert. Recall earlier that I had converted a string to an int. So, based on that, I think what's happening is that the system time is being converted or casted, whatever you want to call it, into seconds. So, I'm going to grab this casting bit real quick. And maybe what I can do is make a variable to hold the number of seconds. And perhaps an int will work. And it does not, because I forgot to change the value of this thing to my system time object. And now I don't see any errors, so I guess this is gonna work. The next thing that I have to do is continually check whether or not the trigger variable is active. Now, I don't have a trigger variable just yet. I'll create it later. For now, I'll create the parameter for that trigger variable in the timer function. So, I am checking if the trigger is active. As for the parameter, I'm going to make it a string, like I did earlier. And I'm going to make it a pointer, because this thing has to directly access the value of the trigger and not a copy of it. And I'm just going to call it trigger. Now, to continually check the value of the trigger, what I need is basically an infinite loop. So a while loop would work quite nicely. And now what I need is a condition to keep this while loop going. So I'm going to make it a string and call it timer loop status, and make it equal to running. So then the condition is while timer loop status is running, this loop runs. And here, I'm going to put the mutex because this is where the shared resource will be accessed. But I'll do that later. And what I'm also going to do is change the function type to int because I have to return 0 to exit this thing. So, on to accessing the shared resource. So, if trigger, or rather the value of trigger, is equal to, I'm just going to call it running as well, then what I want to do is determine how long the timer has been running for. So to do that, I need the date that the timer ended on in seconds. Then I need to convert that into an int so that I can do math on it. Now I need to calculate the running time. So I'm going to make a variable, call it running time. And I want to find the difference, so the end time minus the start time. But first I have to fix this error. I forgot to rename something, so I'm going to do that real quick. Not to mention the fact that I also used the wrong variable, so I'm also going to fix that real quick. Alright, now that that's done, I'm going to print to the terminal how long the timer ran for. And once that happens, I want to exit out of the loop. And to do that, I'm going to set timer loop status to not running. At this point, I need the mutex. So first, before I can use the mutex, I have to include the mutex library. And now that I have done that, I can create the mutex, so I'm going to do that right here. Now, the question is, where do I need a mutex? One has to go here inside of this loop because it is accessing the shared resource. And that's all I'm going to do for now because what I want to do next is create the thread. I don't have a trigger variable to control the thread, so I have to make that first. And now I can create the thread. And here we go. And since I'm using threads, I now have to include the thread library. And that part is done. Now I have to end the thread, and I'm going to do that here. And to do that, I'm just going to take the trigger variable and then change the value of it to not running. Next, what I have to do is join the thread. And I also have to put a mutex here because I am changing the value of the shared resource. So I think I have everything now. Let's see if this works. I'm just gonna generate a password of 10 characters. I don't see any messages on the same line, so everything is synchronized. That's good. There is one little problem though. It said that the password took 0 seconds to generate. It definitely took some amount of time, so I think I'm just not recording the time in small enough or precise enough units. So let's try milliseconds instead of seconds. So here, they are casting the time into seconds. So I'm kind of curious. Can I do milliseconds? Apparently I can. And if that's the case, then I can probably just change the seconds part to milliseconds in the casting function. Time to see if this works. I'm just going to generate a password of 10 characters long. And password was generated in 0 milliseconds. I think I need smaller units. Let's try microseconds. And that appears to have done it. I get a timer output of greater than 0. So, there we have it. Our password generation program now has classes and multithreading. So, what I've shown you so far is the common concepts that you may encounter in whatever programming languages that you may find yourself using. Now, what you'll note is that throughout this walkthrough, I never actually said, this is how you do this thing in C++. Or at least, I didn't say that very often. That's because I wanted to focus on the concepts, with C++ as a tool for demonstrating those concepts. You will also note that what I did was I looked up pretty much everything. Simply put, there's no point in memorizing anything, except for maybe a few common or important concepts. Technology changes quickly, and if you memorize things, well, eventually what you memorize will be out of date. Furthermore, you never know what you have to do until you actually start solving the problem, so it's easier just to look things up as you go along. This is especially true considering that there are tons of free resources available which are freely available. So, that said, what I'm going to do now is show you how easy it is to learn pretty much any programming language once you know these common concepts. And I'm going to do this by recreating most of this password generation program, but in Python. So at this point, take a moment to set up development tools for Python.